This is an introduction to M1. M1 stands for mechanics. So we have mechanics M1. Before talking about mechanics, let's talk about a little bit of physics, because mechanics is a part of physics. So it's important to have an idea where does mechanics lie in the repertoire of physics. So when we talk about physics, let me move a bit here. So when we talk about physics, we are actually breaking physics down into two parts. So physics can be broken down into two parts. Let me draw a timeline here. Broken down into two parts: 1900, after 1900, and before 1900. Now after 1900 it's called modern physics, and before 1900 it's called classical physics. Classical physics in turn is broken down into two parts. One is called electromagnetism, this is 1800. So we can say that 1800 to 1900, all the discoveries and the fascination of physics was electromagnetism. And the other one is mechanics. Now mechanics is the study from 1700, we can roughly speaking. So 1700 to 1800, it was all the craze was mechanics. Then from 1800 to 1900 it was electromagnetism. So mechanics is what we are talking about here. Now just for interest, for the sake of interest, modern physics is broken down into relativity, both the general theory and the special theory. Then we have quantum mechanics. So you have this extreme here, mechanics, and you have quantum mechanics. Actually, if someone wants to study physics now, they would be actually studying quantum mechanics. So this is the overall view, and if you want to know about the person behind it, when we talk about mechanics, we are talking about one person, and that is Sir Isaac Newton. So that's his work. When we're talking about electromagnetism, we are actually talking about Maxwell. When we're talking about relativity, we are talking about Einstein, T-E-I-N, and we are talking about quantum mechanics. A lot of credit. There are many people who worked on quantum mechanics, who are the foundation, worked on the foundation of quantum mechanics. But if you had to name one person who was always very fascinated and very passionate about this topic, was Niels Bohr. So that's the entire physics that we have here. So we are talking about mechanics. Now mechanics is based on Newton's book called Principia. So this course is actually a little portion of Principia, which was written in it was written in the late 1600s. It was published, and it was written in Latin. At that time the mode of education was Latin. So although Newton was from England, it was one of the greatest book of all time was written in Latin, Principia. The full name was Principia Mathematica, the principles of mathematics. So this is what we are doing here, mechanics. The M1 syllabus would be a portion of mechanics. So this is the beginning and the fundamental of physics. So it's a branch of physics, and it is one of the most essential thing of physics that you learn before you start into the main meat of physics, so to speak. So mechanics is the study of motion. Very simply, mechanics is the study of motion and the effect of force on motion, to be precise. So this is the study of motion in short. So study of force and motion. So when we are talking about, let me write the study of force and motion. So when we are talking about the study of force and motion, we are talking about mechanics. Now we are not going to talk about everything of mechanics in the M1 paper. This is an AS paper, and there's going to be in the exam around 5 to 6 questions, usually 6 questions, sometimes it can be 7 questions, and it's going to be pretty straightforward, and this is going to be a very basic paper. Of course there is M2 and M3 and M4, and things become more difficult there. So the first thing that we have to do here is the concept of mathematical modeling. Of course there will be no question set on this, but this is essential in understanding what type of paper this is going to be. The mathematical modeling. Now mathematical modeling is, the first thing is that physics is perhaps the most important subject ever. So if someone wants to study something, if it is science, it is ultimately physics. No matter what subject it is physics. So physics is the essential science. It is the mother of all science. If you want to understand God's world, you have to understand physics. So physics is perhaps the most important subject in the world. Another important subject is economics. That is how you want to, if you want to understand how man's world function, how the world and the social structure functions, that's economics. Anyway, but physics, it's realistic, but what we're going to do here, it's not realistic, it's simplistic. You have to understand realistic physics is very difficult, extremely difficult to grasp for us. So we cannot think about the 3D world. As a matter of fact, we cannot even understand very clearly the 2D world here. We're going to do 1D. Everything is going to be one dimensional, it's going to be linear, a motion in a straight line. So it is going to be so simplistic that in M1 everything that we do is going to be in 1D. If something is moving, it will not be moving left or right, up or down, it will be moving in one straight line. If something is thrown, we will consider thrown in a straight line. So it's not going to be realistic, it is going to be simplistic. So when we talk about simplistic, we are talking about modeling. So it's not real, it's a model. So here instead of taking an actual person, we're going to consider him to be a particle, and the particle which here in M1 represents an actual person is obviously unrealistic. How can a person be a particle? A particle is just a point. Again, if we have some sort of a rope which is exist in reality, we're going to consider it to be a string, something that cannot have the real properties that we see. So everything is going to be modeling. So there will be no question directly based on modeling, but the entire M1, the idea of M1, the spirit of M1 is based on this concept of mathematical modeling. Now the first real topic is kinematics. Kine means motion, as in cinema, it came from that. Kine means motion, so kinematics means the description of motion. So this is the description of motion. So here they're going to give either one or sometimes two sums. So you can assume that there can be two sums from kinematics. So one question we can assume one question about motion. So description of motion, it can be horizontal motion or it could be vertical motion. So when we are talking about one question on either horizontal motion, meaning the object is moving horizontally or it is moving vertically. So there is going to be one question either on horizontal motion. Chances are it's going to be horizontal motion because vertical motion is not that regular. And there's going to be another question on sketch or graphs of motion. The most common here is the velocity time graph. This is the most common. Of course, there are other graphs, displacement time graph and acceleration time graph, but this is the most common, and I think almost always velocity time graph is given in the exam. So we can expect two questions, one and another one here from kinematics, the description of motions. The next thing that we have is, after you describe the motion, the next thing is a topic on force. So we have statics, it is force and equilibrium, or forces in equilibrium. That means force is applied and the object is still not moving. So this is forces in equilibrium or force in equilibrium. So here there is going to be one question in the exam regarding statics, and the question is going to be like this. The question is going to be either no surface, that means suppose you have an object here and there is a string pulling it here, there is another string pulling it here, and that string itself is attached to some support and it has weight and it is balanced completely, it is in equilibrium. So we want to find something unknown, some sort of an unknown force here when we have an object, it is not touching any surface and it is something like that. And it can either be this or it can be a question with a surface. So with contact with surface, we can write contact with surface. That means in this particular case there is going to be a surface and there is going to be contact with a surface. It can be something like this. There is an object, someone is trying to pull this and someone else is going to pull it in this way, and this is not moving now. So this is something of an equilibrium, it's not moving, obviously it's statics, it's not going to move, but it has a surface now. Because of that surface, the weight is going to have an effect here, and there is going to be an opposite but equal reaction from the surface. So from a contact surface you have this reaction force, a new concept of a force. Surfaces can be either plain horizontal surface or it can be an inclined plane. So the surface, this surface can be inclined as well. In that case we can have something being pulled like this and the weight is working here and the normal reaction is here. So this is also in equilibrium, this can also be in equilibrium, and but here we have an inclined plane. So this is an inclined plane and this is a horizontal plane, and the quality of the plane can be smooth, meaning no resistance to motion, or it can have some sort of a resistance to motion known as friction. So there's going to be one question from statics. It's either going to be no surface where you just things are hanging around, or it is going to have some sort of a surface. So far we have three questions. The next one that we have, it's called dynamics. Dynamics means forces or force and motion. So force is being applied and things are moving. So that's how simple it is. Now there is going to be two questions from here. Now one of the question is going to be just like statics, it is exactly the same. This time it is going to be contact with surface, and the surface can be like this, it can be moving in this direction, or it can be on an inclined plane and it can be moving. So here that object would be moving and it is going to be moving with contact with a surface. So this is how it's going to happen. Or and there is another question going to be with connected particles. Now connected particles can be of two types. One type of connected particles, they're connected like this with a string, so the object is moving forward and they're connected like that. Another thing can be they're connected through some sort of a pulley. So you can have this object and this object going over a pulley. A pulley is some sort of a device to put chains around it and to have an to raise something with that. That's a pulley. So we can have a sum with the pulley, connecting with the pulley, or we can have two objects just connected like a car pulling another car. And of course, in both the cases, the surface can be horizontal or it can be inclined. It can be like this, and also the pulley can be like this. You can have this object and the pulley can be here, it can be hanging here. So there are actually two types of connected particles here, and each of them, they have two types. So there is another question here, and we are going to have a connected particles, no question about that. We can either have this or we might not have this. So far we have 4 questions. The next one, it's momentum. Momentum is the combined effect of mass and velocity on impact. So when someone punches someone, there is a combined effect of the fist, the mass of the fist, and the velocity with which the fist is landing. So this is momentum. Momentum is all about collision, it's all about impact. So there is going to be one question on momentum, and that question is going to be about collision. So there can be either one of the collision. When we have two objects here, one might be hitting and the other might be coming in the opposite direction, or there might be two objects here, one object at rest, the other object is coming and hitting this, or there can be two objects connected together and there is some sort of an explosion so that they just go off in either direction. So there can be 3 or 4 situations. One of them would be given in the exam, and that's collision. And there is another question at the end of a collision which is based on impulse. Impulse is the amount of force that you have to apply for a certain amount of time to make momentum, to change momentum. So it's the effect of force and time to change momentum. So that's impulse. The next question is going to be on moment. Now moment refers to the turning effect of force. So whenever a force is used to turn something, so turning effect of force, this is also called as torque, T-O-R-Q-U-E. So whenever you're trying to rotate something or you're trying to turn something, that if that combination of force and distance, because when you turn something, distance plays a role, that combination is called moment. And there's going to be one question on moment. There is no doubt about it, there will be definitely one question on moment. And there are two types of moment sum. It can be like this, fixed, pivot is fixed, and you can just, like a hinge, you can turn this either in this direction, in the anti-clockwise direction, or in this direction, in the clockwise direction. And another one is that you can have a support here. So when you move this is actually not fixed, but it can work like a pivot, like a fulcrum. So what happens, it works like a moment, it's turning. So there are two types of sums. Either in your exam it could be given that it's a fixed pivot, or it could be an unfixed pivot, which we call a support. So far we have how many sums? There will be no sum on mathematical modeling. There will be one sum on kinematics, another sum on kinematic graphs, there will be one sum on statics, then there will be one sum on connected particles, there can be another sum on dynamics, there will be one sum on momentum, and there will be one sum on moment. So 1 2 3 4 5, 6. Now the seventh question, or there could be only 6 questions. The seventh question is going to be on vectors. Now vector is actually by itself, it's nothing, it's a tool. Vector is like that part of the mathematical modeling. When we talk about vectors, we are talking about the mathematical modeling, because after all, when we talk about kinematics, description of motion, we can assume them to be vectors. A vector, by the way, is a line with a direction. Remember, in mathematical modeling we said we don't do the sums in the 3D world. We don't even do it in the 2D world. We just do it in the 1D world, meaning linear motion, motion in a line in one direction, a line with a direction. So this vector is actually part of the mathematical modeling. Vector itself is nothing, it's not a concept of physics. It's actually a tool of doing physics, sums in physics. So it's a tool. So what we do here is we are going to have one question on vector. Now that question, definitely there will be a question on vector. That question can be a displacement vector. Displacement vector sum is a big vector sum worth 10 to 15 marks. So it could be like that, where we have to find the position of a vector, or it could be force, or actually kinematics sum couched in a vector sum. So it could be force equals to mass into acceleration. Here the acceleration can be given in the vector format, in the mathematical modeling format. So there can be 3 or 4 mark sum here, or it could be a big sum. So it depends on the other sums whether the vector sum would be a displacement big one, or a little bit of force or kinematic sums. So in a nutshell, so these are the 6 or 7 sums that will be given in the M1 exam. So there is going to be, if we review this, there is going to be a kinematic sum. Actually there is going to be 2 kinematic sum. There is going to be static sum. There is going to be 1 or 2, chances are 1, dynamics, connected particles. There is going to be 1 momentum sum. There is going to be 1 moment sum, and there is going to be 1 vector sum. Now in this exam there are going to be definitions given, and you have to show that you understand the concept of mechanics. Now the most important thing for any exam is to read the syllabus, and to have the syllabus in your hand. That might be a bit troublesome to read the paper 3 or 4 or 5 pages all the time. So what I have done, I have made a mind map. So I've made a mind map out of the syllabus. A mind map is nothing but something that makes a picture out of lots of written pages. So this is the mind map of the M1 syllabus, from the edXL M1 syllabus, and it has all the information that you need from the syllabus. So what you need to do, you have to keep this mind map with you so that you don't miss anything, and you know when you're studying, if you have a problem, what is the problem area. So let's take a look at the mind map. Let me zoom this out a little bit. Okay, so let me review. So the first thing that we have to do here, mind maps, is kinematics. So kinematics means the description of motion. So there is going to be either horizontal motion sum or vertical motion sum, and there is going to be motion graphs, velocity time graph, displacement time graph, and acceleration time graph. This is the question structure. Now here we have some definition, theories and laws in the exam. So in kinematics we need to know Newton's first law of motion. Then we have, after kinematics, we have momentum. Momentum is the effect of mass and velocity on impact. So when we have the combination, the combined effect of mass and velocity when something is hit, we have that. So the sums are collision sums, and there are many types of collision, when two things are hitting each other from opposite direction, or one is hitting the other one, or there's an explosion and they're split and they move in opposite directions. It could be like that, one of the situation in the exam. You need to know Newton's third law of motion for momentum, and you need to know the law of conservation of momentum. Then we have moment. Moment is turning effect of force. So we have two questions, a question regarding fixed pivot, or we have non-fixed support. There's going to be either one of it in the exam. And we have the law of conservation of moments for this the theoric part, and we have to know the definitions of particles and uniform rod here. And next we have statics. Statics means force and equilibrium, or forces in equilibrium. So we have a static sum, either it has no surface, meaning hanging in midair, or it can be different types of surface, like a surface that is horizontal or inclined, and the surface quality can be smooth surface or rough surface. Rough surface means surface that has friction. Dynamics means force and motion. The force is now causing motion. So here we have either a single particle sum or a connected particle sum. As a matter of fact, connected particle sum would be given for sure. This is one question that is always given. Dynamics here, single particle sum might be given, might not be given. Or if this single particle sum is given, then the static single particle sum will not be given, because both statics and dynamics have single particle sums and they're similar to each other. So here the surface can be again horizontal or inclined, or the quality of the surface can be smooth or rough. So this thing and this thing is the same thing, absolutely the same. The only difference is that this is moving, dynamics, and this is not moving. And connected particles can be connected particles through pulleys, or it could be through non-pulleys. And one more thing is vector. Now vector is a tool of doing mechanics. It's by itself, it's not a concept, so it's just a line with a direction. So this sum, there's going to be a sum on resultant vector, or it could be a sum on displacement vectors. And one more concept is the concept of mathematical modeling. This is required. You don't have to do any sum on mathematical modeling, but you need to know the background of mathematical modeling and how does this work. Now let's take a look at the book. Now this is the live text version of the book. It's an interactive book. I recommend that you use this book, because this book has all the exercises and the solution of the exercise. All you have to do, if you click on the solution hotspot, as they say it, and you'll get the all the sums done step by step. There's also a cool feature called Exam Cafe, where you can actually prepare for the exam and you can see what it looks like. So let me just briefly go through the book. So these are the notation. This is the Exam Cafe and this is the solution bank, where you can have every single sum done. Then let's move on to the content page. We have the first topic as mathematical modeling, then we have kinematics, then we have dynamics, then we have statics, then we have moment, and we have vectors. The syllabus is not that big. We have 2 review exercises and 1 exam style paper. So this is how you use the book, the live text. Let me show you how to do the solution. So suppose you're doing the exercises, and one of the exercise, so you have this, you're doing the exercises and you have this S written here. Okay, now you have these exercises, and as you're doing it, if you press this PDF button, you'll get only the answers. Let me press it here. So you can see that this is the answer. So we are getting the answers here. So when you press that, you're going to get that answer, all the answer to the exercises of this particular chapter. So that's that PDF button. And beside that, you have another button, the solution button. So if you press the solution button, you're going to get the step-by-step interactive solution. I think here the default has to be the Internet Explorer, so that has to be done. I don't think in this PC the default is Internet Explorer, so that's what you have to do. So when you click this, you'll get the solution bank, and this is how it works. So when you have to do this, it's a good idea to have the syllabus with you and to have the book with you, so that you can see how the whole thing is working. So this is the introduction to mechanics M1. And one more thing is that there will be a formula booklet given in the exam. So this is the formula booklet. So if you can see, so this formula booklet will be provided in the exam to be used. Now if you look up in the table of content in M1, there are no formula given for M1 in addition to those candidates are expected to know. So whatever formula that there are, you will not get that in M1. So there are some formula given in the other papers, but in M1 there is no formula given at all. So you have to memorize all the formula.